Hi everyone. So let's start again with our brownies. So here we have once again that recipe for making 24 brownies. This time I'm just going to change the prompt a little bit. So now I want to know what mass of brownies, basically how many grams of brownies can I make if I have 200 grams of chocolate chips. Now, things to keep in mind here. 1 cup of chocolate chips is 150 grams, and my 24 brownies would have a mass of 1,250 grams. Seems a little daunting at first, but just taking a minute to think about it, truly not all that difficult. So I want to know how many mass of brownies what the mass of brownies will be that I can make, judging by the starting amount of ingredients. So if I have 200 grams of chocolate chips, well, let me find out how many brownies I can make me. Well, if I've got 200 grams of chocolate chips, and I know that 1 cup is 150 grams, well, that's basically 4/3 of a cup. And because that 1 cup makes 24 brownies, multiplying that by 24, I can make 32 brownies. Awesome. So my 200 grams of chocolate chips, assuming that I have plenty of all the other ingredients, I can make 32 brownies. Cool. Now that I know how many brownies I can make, I just want to know lastly what the mass of all these 32 brownies is going to be. Well, I know that 24 brownies has a mass of 1,250 grams. So just taking 1,250 grams, dividing it by 24 brownies will essentially give me the gram per brownie times 32 brownies. And my 32 brownies will have a mass of 1,666.67 grams. Doesn't seem all that abstract, right? Once we knew how many brownies we were going to make, it was pretty easy taking this 24 with the mass to figure out what the mass of the 32 brownies are going to be. Okay. Once again, let's change up the scenario a little bit. Let's go back to ammonia. So here we want to know how many grams of ammonia can I make if I have 15 grams of hydrogen. So much like in this previous example, I'm starting with grams of an ingredient and I want to know the grams of whatever I'm making. So here, from the grams of chocolate chips, we figured out how many brownies we can make. And then from the brownies, we figured out the mass. The only difference here is, is that instead of starting with starting with cups and chocolate chips, we have 15 grams of hydrogen. Well, here we know moles of hydrogen that go into the recipe. So our 15 grams, much like how previously we figured out how many cups of chocolate chips went into it, we got to figure out how many moles of hydrogen this is. Well, just converting grams into moles is easy enough, just dividing by the molar mass of hydrogen. So here, we should get roughly 7.5 moles of hydrogen. Awesome. So now that we have 7.5 moles of hydrogen, we are interested in knowing about ammonia. Well, we know that 3 moles of hydrogen create 2 moles of ammonia. So let's take our ratio here. 2 NH3s for every 3 hydrogens. This is our mole to mole conversion. So this makes roughly 4.95 moles of ammonia. Now we have a quantity in terms of our product. Just like how we figured out we had 32 brownies, now we figured out we have 4.95 moles of ammonia. Lastly, I want to know grams of ammonia. So just like how before, we want to know the mass of the brownies. Now I want to know the mass of the ammonia. Well, we can convert moles into grams by multiplying by the molar mass of ammonia for every 1 mole. And that gets us roughly 84.83 grams of ammonia. This one may seem a little more abstract just because we're not really used to making ammonia at home. The brownie example is probably a bit easier to follow. But in the brownie example, we started with 200 grams of chocolate chips and we converted all the way to grams of brownies. This is essentially a full chain of stoichiometry, taking a gram given amount of a substance and converting it into grams of another substance. So in stoichiometry, what we're going to focus on now is the full gram to gram conversion. So we've covered mole to mole stoichiometry, going from moles of a substance A to moles of a substance B by multiplying against the mole ratio. Again, right here, the mole ratio taken directly from the coefficients of a reaction. Now, we are just going to add to that, changing from gram to gram. The reason for this is just practicality. If we're doing a lab or some kind of experiment, you can't measure out moles. Scientists don't really deal with moles because of the fact that there's no scale that you could just put on and get moles from. We have to work with grams because when we're doing things, everything physically that we're working with is grams. But we have to be able to convert grams of one thing to grams of another. That way we either know how many grams of another reactant we're going to need to match it, or how many grams of product we're going to be making in the end. This mole ratio can only work for moles, because that's how we compare substances in chemistry. So the chain of gram to gram stoichiometry is as follows. You take grams of a substance A, convert it into moles, take moles of your substance A, and convert them into moles of a substance B, a different substance, and you just turn that into grams of your substance B. So let's take a look at an example here. Ammonia is made by the reaction of nitrogen with hydrogen. So our balanced reaction comes to the coefficients 1, 3, and 2. We want to know how many grams of hydrogen are needed to react with 56 grams of nitrogen. So we have 56 grams of nitrogen, and we have to get all the way to grams of hydrogen. Well, before I can ever use my mole ratio, I need moles. Grams are pretty much pointless to me. So we have to be able to convert these grams into moles by dividing by the molar mass of nitrogen. Keep in mind this is N2, so it would be 28 grams. So our 56 grams of nitrogen is essentially 2 moles of nitrogen. Now that I have moles of my substance A, in this case nitrogen, I can turn this into moles of a substance B by multiplying by the ratio. The ratio again coming straight from my reaction. Well, my reaction tells me that every 1 nitrogen requires 3 hydrogens to go with it. So there's going to be 3 hydrogens for every 1 nitrogen, which means if I have 2 moles of nitrogen, I will need 6 moles of hydrogen. And now lastly, because I want to know how many grams of hydrogen are needed, I could just take that, multiply by the molar mass of hydrogen, and I will need 12.12 grams of hydrogen. So 56 grams of nitrogen require 12.12 grams of hydrogen in order to react completely. Now to kind of changing up some substances here, we want to know, okay, how many moles of NH3 can be produced if I have those 56 grams of nitrogen. Now we're just assuming that the hydrogen is correct, so we just want to figure out how much ammonia I can make with the 56 grams. Well, we already know that 56 grams of nitrogen is 2 moles of nitrogen. But now instead of converting to hydrogen, I'm going to convert to ammonia, because now I care about ammonia. We don't care about hydrogen anymore, because hydrogen we're assuming we're fine. So our ratio is going to be a little different now. 1 nitrogen creates 2 ammonia molecules. So we're going to make 2 ammonias for every 1 nitrogen molecule. So if I have 2 nitrogen molecules, moles, times the 2/1 ratio, I can produce 4 moles of NH3. And then from here, I can go ahead and convert it into grams if I want to. So it's no different than what we had just done, mole to mole conversion, multiplying by the B over A, except we're just adding grams into the mix for practicality. We have to know how to convert and do all this math with grams.